you ever seen Otherwise, on there has one of those. He's got like a keyboard on it.
I just keep on charging.
It's just like,
Yep.
okay, this is just ridiculous.
All right, so let's go ahead and get started. The recorder is up and running.
On it, and I have a keyboard and mouse for it. So
Okay, well, I hope you guys got a nice break. You know, did you guys get a nice break?
Not
It's
really.
okay? Not really?
I had a bunch of stuff to do.
Not much to do.
No, I had a lot of stuff.
Oh,
to
you
do.
had, okay. So you didn't get a whole lot of time to rest.
Exactly.
Same here. So. Well, finally, we have the practice question for the second examination. So that's what we'll do today is to take a look at the second examination questions. It's not going to be very, different from the ones that you have seen already, but I just want to give you guys more exposure. So we'll go ahead and get started with that. If you have any questions about those questions, or if you have any issues with those questions, let me know. The second exam, because we're going through the practice exam today, that means next Tuesday is the actual exam date. So next Tuesday is our second exam. It's really close to the final exam, which is kind of good in a way and bad in a way. It's good in a way because it gives you, basically a good, practice for the final exam. The final exam is worth 40% of your grade, and then the second exam is only 20%. So this 20% is kind of like a warm-up for the final exam. And the final exam will have a skew to the material toward the end of the semester too. So the second exam is really, I think it's the timing is just about right at this time. All right, so for those of you who have tried to click this link, did you guys have any problem bringing up the Google Documents? Because that's what I did. I used Google Documents to type up, this practice exam. Your actual exam is not going to be in the same format because I have to give you, like pre-formatted lines, and then you still need your rulers. Okay, so for next exam, you need to bring your rulers to basically draw all the vertical lines. I will give you all the horizontal lines, but you have to draw your own vertical lines. If you prefer to have your own paper, you can bring your own paper as well. Okay. Are there any questions? Yep. No? Okay, I thought you had a question. All right. So we'll go ahead and get started with this one first. And let's see, do I have a zoom control here? Nope. Well, I can control, just the zoom. Yeah, Google doesn't like that. Google Apps doesn't like it when I change the zoom.
Can you put
All
it
right.
in a presentation mode and you release the top bar?
Yeah, we can get rid of the top bar, but it doesn't really help that much, especially when we have to trace it. So what I'll do is I try to copy and paste this into my spreadsheet because I have to trace it here anyway. I thought about those questions, like how am I going to ask questions for this exam, and I still find it really difficult to come up with questions that are easy to grade. In other words, you just have to fill in one line or one unknown. So, okay, it popped up the window over here. That's why it didn't appear on the other side. All right, so let's see how well it can copy and paste here. Not too bad. And we just have to fix up the fonts a little bit. Go to, and then fix the indentation. I thought about using OpenOffice to type everything, but then I decided against it. There we go. Okay, I think that's good enough. So this is the first question as in our practice exam. It's not really that difficult. It doesn't have recursion. So this is one thing that I was trying to do with this exam, was not to put everything into every single question. So each question has a kind of specific thing that it wants to test. So this way, if someone doesn't understand a particular concept, will not suffer from all the questions. Only one of them will ask that sort of question. So we'll go ahead and trace this particular program. we'll just go ahead and take a quick look at this program first before we trace it. The only line outside of any subroutine definition is on line 10. Line 10 says, we want to invoke 4, and then we take whatever it returns and print it out. Then we go to subroutine 4, it wants to invoke subroutine 2, and then plus 2 to the result of, or the return value of subroutine 2. Subroutine 2 is going to invoke 1 and invoke 1 again, and each time you invoke 1, it simply returns 1. So it's really just a very difficult and long way to compute 4. But what I'm trying to test here is whether people understand the concept of returning a value. You can see that there are no parameters, there are no local variables, there's no recursion either. So this is all just about return values. Okay, so we'll go ahead and track this down. We need comments in the trace because there is a print, but we don't need to take a look at comments for the time being. There's the line number, and we don't have any global variables. So the pre has nothing to say because there are no global variables, and there's nothing, there are no variables or parameters whatsoever. There's only return info in this particular trace, which makes it kind of interesting because we haven't really seen programs that behave like this in our this normal discussion. We start on line 10. Line 10 is, well, we cannot do the print yet because we don't know what 4 is returning. So the first thing we have to do is to invoke 4 and figure out what it is going to return. So that means we need to know where to come back to, because every time you invoke a subroutine, you kind of have to remember, okay, when the subroutine is done, what else do I have to do? So what do you think we should do here? Should we use return line number or return info? Return info, because we are not just returning to a single line, there's more stuff to do on that line. So return info is the correct label. And what do we put here? Well, you have to basically spell out the entire line on line 10, except the subroutine itself, or the invocation of the subroutine is replaced by a single question mark, which is the placeholder for the return value. Are we doing okay so far with this? Because once you get this part done, the rest is pretty much the same. I mean, it's really kind of boring after a while. Then we go into the subroutine. The first line in subroutine 4 that is actually useful is line 8. Line 8 says we want to return the return value of invoke 2, but we want to add 2 to it first before we return that value. We cannot execute the return just yet because we have to figure out what 2 is going to return. So that means, once again, we need return info, and this time we are returning back to line 8, except on line 8, when we are all done, the question mark will be replaced by a specific value, but we still have to remember to add 2 to it at that point. Are we doing okay so far with this trace? Okay. And then we go into the subroutine call 2 on line 4, but since line 4 is just the beginning of the subroutine, it doesn't do anything. Now we go to line 5. Now line 5 is a little bit more tricky. It is a little bit more tricky because we are it's a little bit more tricky because this time it returns the return value of invoke 1, and then it returns the value of invoke 1 again. So what we need to do here is obviously a return info because we cannot execute the return statement just yet. The question now is, what do we put inside the return info? Well, we have line 5, that part is for sure. We still have to return a value. And this time you have to remember, we can only deal with one invocation at a time. So that means, let me just slide this one over a little bit here, or I can change the zoom. And I think that's probably best. Just change the zoom a little bit so that we can see the entire line. Is that still okay? People in the back can still read it? So what we are doing here on line 5, the first time we get to line 5, we have to resolve what the first invoke 1 is returning. Now I know you can see that it's invoking 1 and then it's invoking 1, but there's no guarantee that each invocation is going to return the same value. There's just no guarantee. In this particular program, yes, it does return the same value because you can look into the definition of subroutine 1, it just returns a constant of 1. But what if it is returning the value of a global variable? and the global variable changes every time you invoke the subroutine, then it may not be returning the same value every single time. So that's why it is important to only deal with one invocation at a time. Do not assume that it's going to return the same value. Now once we set up column E, then we can get into the subroutine. Subroutine 1 on line 2. Line 2 is the simplest line of the entire program. All it does is to say, well, let's return a value of 1. To return a value of 1, you just take, copy and paste the return info cell, change the question mark to a 1, and you're done. Do we have any questions about this one? Because this is the first time we execute a return statement. We have not executed any return statements up to this point because all the other return statements cannot execute because they all depend on the return value of another subroutine. Is the concept okay so far? Okay. Now this part depends on how you want to do it. If you prefer, you can just then we have to go to line 3. Okay, let's not forget line 3. Line 3 has 2 tasks to perform. One is to look up the return info cell. If you want to, and you don't mind, just writing a little bit more stuff, you can copy and paste that line, into the line number, just so that we know what line 5 looks like at this point. Because otherwise, if we just say that we're going back to line 5, well, line 5 looks like this in the program, but that's not what it looks like right now because we have just resolved the return value of the first invocation of 1. So this is up to you. You don't have to do it this way. If it were up to me, at least consistent with the notes, I just say it's returning to line 5, and then we have to deallocate this particular column. Now this part you have to do because I have to know that you understand that at the end of an invocation, whatever columns you allocate for that invocation will have to be deallocated. Are we doing okay so far with this? Now line 5 looks like this now. So that means, can we do the return yet at this point? We cannot do it because there's another invoke 1. So that means on line 5, when we're back to line 5, we have to do pretty much the same thing. Except the return info cell is not going to look like this because the first one is already resolved to a 1. It is time to resolve the second one. And that's why only the second one gets replaced by a question mark because that's the only invocation we are dealing with at this point. Are there any questions about column E at this point? No questions? Okay. And then we go into the subroutine, go to line 2, it executes return 1, we copy and paste the return info cell, change the only question mark to a 1, and then we go to line 3, just like before. Line 3 does the same thing as before. We have to deallocate the column, and then now we go back to line 5 again. But line 5 now looks like this, return 1 plus 1. Can we calculate 1 plus 1?
Yeah.
We can calculate 1 plus 1 is just 2, right? So that means we are ready to execute this return statement on line 5. Returning 2 means we have to look up the return info cell, copy and paste it, change the question mark to a value of 2 in this case. So that means when we get back to line 5 this time, we can actually execute this statement which changes this particular cell. Is that okay? We are executing this statement. It is fully resolved. We are now ready to execute the return statement. But as a result of executing this statement, we are changing this cell so that we now know the question mark should now be have a value of 2. Now this part is important. Most people can go forward. That's not a problem. Most people have problems going backwards, or in this case, some people put 2 question marks here and resolve both question marks to 1 at the same time, and that would also be incorrect. Are we doing okay so far with this? Yeah. Okay. Now we have already executed line 5, so this statement, there's nothing we can do about this statement at this point. Now we go to line 6. Line 6 is the end of the subroutine call 2, so it is time to mark that this column is no longer needed, and then now we go back to line 8. When we get back to line 8 looks like this. Well, we can compute 2 plus 2. In other words, the return value is fully resolved at this point. Return 2 plus 2 is to return 4. Return 4 means that we have to copy and paste the return info cell, change the question mark to the value of 4, and we are done. But we do not execute line 10 at this point because we have to go back to line 9 and say that, okay, well, this column is no longer needed, so we'll deallocate this column, and now we are back to line 10. When we get back to line 10 looks like this, print 4. Well, there's nothing else to resolve at this point, so you just need to say that it is printing a value of 4, and we're done. Are there any questions about this trace? Yep, go ahead.
On line 5, can you just kind
Line 5 or row 5? Of the trace.
Oh wait, row 15.
Row 15.
Yeah, where you put line 8 on there for return. I don't understand how you got
That line 8 comes from here.
Oh, okay.
When we first set up the return info cell, we already know that we have to get back to line 8 because it is the result of executing line 8.
Okay.
Because line 8 is invoking the subroutine called 2. So when we executed line 8 the first time, we allocated the return info cell, and then this is what we remember. To
Okay.
remind ourselves what else do we have to do when we get back to line 8 after the invocation.
Okay, I see.
Any other questions about this one? As I said, I'm trying to isolate different concepts into different questions. So this one, for the most part, only has to do with return values, but it does have certain things that are a little bit tricky. Like line 5 is just a little bit tricky, but not too bad. Shall we move on?
Are you going to post these files to the
If
to
you
Moodle?
remind me, I can post it to Moodle. Yes.
I will email you right now.
Let me save it to today's folder first, so I can save the entire folder. This is exam 2, question 1. It's just a practice question. Just setting up for the next one. Oh, I guess I have 2 titles. One. And let's see. All right, so that's question number 1. Let's move on to question number 2. Question number 2 is a little bit longer, and this one does have a local variable as well as a pass-by reference parameter. So we'll go ahead and do the same thing, copy and paste it into a spreadsheet. And change the format a little bit because it's always messed up like this. And change the indentation. That one is outside. There's only one subroutine in this case. There we go. And then we can compact it this way. There we go. Now it looks good. All right, so before we begin, we'll take a look at this program. Line 8 is the first line outside of the definition of a subroutine. So this time we do have a global variable I. We have a subroutine called inc for increment. It takes one parameter, which is x. It has a local variable y. It has certain assignment operations in it, and then it returns the value of y. And we are going to print the return value of inc here, and then we'll go ahead and print the value of I itself. So the question is, what do you think is going to print and what in both statements? That's the question. We'll go ahead and trace it. And before we do that, we can save the file first, just so that I don't forget to do it. This is exam 2, question 2. Right. We do need comments because we have 2 print statements later on. But for now, we can just kind of scroll it off because we don't need the comments column until much later. We have line number, and we have a global variable I in this case. So in this particular program, you have to allocate a column for variable I right off the bat because it is a global variable. that okay? Does everybody understand why it is important to allocate column C for variable I at this point? Because it's a global, so it starts to exist as soon as the program starts running. So now we do have something to say about the precondition. Well, since I didn't say anything about I, you can assume that it has an unknown value. It has a value, we just don't know what it is. Then we start execution on line 8. Line 8 does something very simple. It just changes the value of I to 4. Then we go to line 9. Line 9 is the invocation of a subroutine, and then when we come back, we have to print the return value. So that means we have to use a return info in this case. And then it has to say, okay, we have to get back to line 8. The print part is not done, but we're going to print the return value of the subroutine. After that, you have to set up the additional columns, because in this case, we do have one pass by reference parameter as well as a local variable y. For local variables, it is pretty easy, because what is the initial value of any local variables? It's question mark. We do not know. Okay, so that part is important. And what about x? X is passed by reference. What does it mean when we pass something by reference?
Column C. It becomes the reference to column C.
It becomes a reference to column C. Remember the Stargate analogy? Okay. So we are opening up, we are dialing the Stargate now. So this is AKA column C in this case. Whatever you do on this end, with this Stargate, it is all happening on column C. All right. So now what do? We continue execution in the subroutine. The subroutine doesn't do anything that is particularly tricky. It copies the value of x to y. So we reach into the Stargate here, and it opens up, on column C. So that's why it is going to grab a value of 4. We take the value of 4 and then we copy it to our local variable y, so y ends up with a value of 4. Is that okay so far? And then we move on to line 5. Line 5 says we want to add 1 to x. In other words, we're adding 1 to whatever this particular Stargates connect to. Okay? We just put some additional content into the coffee mug, if you will. So we are putting, we are just adding 1 to it. So now I gets a value of 5. Then we get to line 6. Line 6 is a very simple return statement. It doesn't have any invoke in the return itself. It's just returning the value of y. Y has a value of 4, so that's the value that we are returning. To return a value means that we are going to go to the return info cell, copy and paste it, and then change the question mark to whatever value that we are supposed to return. In this case, it is 4. Are we doing okay so far with this? All right.
Can you go over what the double arrow means on?
The double arrow is here just so that it is clear that we are passing I by reference to x.
Okay.
It's only used in this class, only used in the pseudocode of this class. When you write actual programs in C++ or Visual Basic, that it doesn't make any difference. In other words, when you just look at the code of C++ and Visual Basic, you would not know whether something is passed by reference or passed by value. But in this class, I make it very clear, because passing by value has a right arrow, and then passing by reference has a double-sided arrow. So in this class, I make it very, very obvious, just so that we are aware of the fact that we are passing by reference.
Okay.
Yep.
Because if that was passed by reference x instead, would you just make x 4 instead of?
If it were passed by value, you mean?
Yeah.
Yeah, if it were passed by value, then x would just have its own value of 4. Because it's a copy of the expression that you are using to specify the parameter. Remember, when you pass by value, a pass by value parameter is essentially a local variable, except it doesn't start with an unknown value. It starts with a value that is specified by the invoke statement. Yep.
Just so I understand, on line 9, it says print invoke inc I by reference x.
Mm-hmm.
Is that what the double arrow means? By reference?
Yeah.
Okay.
So in this class, we have 2 clues that we are passing by reference. One is when you look at the invoke statement, and one is when you get into the subroutine, you can also see that x is passed by reference.
Okay, so one arrow says by value.
If you have a right arrow, it is passed by value in this class. All right, so we are done with line 6. We now move on to line 7. Line 7 is the end of the subroutine. We do the usual thing. We look up the return info cell. We have to go back to line 9 to continue execution. And then we deallocate all the columns that we allocated for this invocation. So we go here, and then we go to format cell, strike through, click OK, and now we are back to line 8. But when we get back to line 8, oops, excuse me, I made a mistake here. This should be line 8, that should be line 9. My mistake. Okay, when we get back to
Return should be on 7.
Yeah.
The allocation.
Okay, this is 7. Okay, I have to move these up. All right, there we go. There we go. Thank you. Okay, so now we're back to line 9, and line 9 looks like this at this point, which means, are we ready to print? Yeah, we're ready to print. So we'll go ahead and say we're printing a value of 4 at this point, and then we move on to line 10. Line 10 just wants to print the value of variable I. Variable I, which is column C, now has a value of 5. So on line 10, we are printing a value of 5, and then we're done. Now this kind of thing looks a little bit tricky, and it looks kind of pointless too. You know, why would I increase the value of an integer, but only to return its old value before it is incremented, before we change the value? You will see this a lot in your next class, cisp300. This is called a post-increment operation. In other words, the increment is done after it returns, or after you can use the current value of the variable. It sounds really obscure. You know, it's look like, you know, well, why would we want to do something like this? In C++ or in regular C programming, this turns out to be a very nifty tool, you know, to kind of help. It helps to compact lines of code. In other words, what would otherwise require like 2 or 3 lines of code can now be compacted into a single line of code, which is not always a good thing. You know, compacting lines of code, you know, is usually not a good thing because it makes the program more difficult to understand. But C has a long history of, you know, not intended, you know, for readability. And if you think C is bad, you know, Perl is even worse. I know really, really good programmers who can write, you know, some really fantastic, you know, Perl code, and then 2 or 3 days later have no idea what he just wrote. It's really that bad. I mean, with Perl, it can be really, really bad. C is not nearly, you know, that bad yet. All right. So, do we have any questions about this particular trace? Yep. Go ahead.
Just for formatting sake, so on line 9, where you invoke inc, I gets or x gets a value, or I gets a value of x, and back and forth we open the Stargate, whatever you want to call it. Could we put that I by reference x in another set of brackets or parentheses to separate it so that we know what we're really doing is just invoking inc, and that's going to return y at the end of it, and not confuse it? I mean, for formatting sake, would you have a problem with that in the comments if we did that on the?
If you put it in the comments, it will be fine. But over here, I think, you know, we should keep the same format here. You can add additional things to it, you know, but I would not change the, you know, I would have at least this much information in the trace.
Okay.
Yep. Yeah, before I would say, you know, I would tell people to just say, you know, this is also known as I, but I don't want to do that anymore because it really refers to the column where variable I lives. In other words, at this point, if you look at, you know, the trace at row 6 of the trace, column C actually has 2 names now. The first name is just, you know, I, which is known as the global variable, but the second name is known as known as x as the passed by reference parameter inside the subroutine inc. In other words, it has an alias, and that's why I use the AKA, you know, also known as acronym, because x really is an alias of the same column that was previously only known as I. Okay. Any questions about this one? Yep, go ahead.
Are you recording right now?
Yes, I am recording.
Okay, I just wanted to make
I'm sure.
All right, great.
Wait. on this side. There we go. It's still recording.
I thought I remember seeing that screen, but
Yeah, I was using the screen switching thing, so it's not as obvious. We want to make sure the volume is still good. Yep, it is. It's still recording. It's good to check.
yeah.
All right. So where were we? Okay, we are done with the second question. So we'll go ahead and save the file first. Okay, so close this, save this, and get ready for the next question. All right, here's our next question. Question number 3. Question number 3 looks awfully simple. And its only purpose is to see whether people understand the concept of recursion. Now, I cannot guarantee that in your exam, questions will be as simple, because, I think, if I can go over this in, very short amount of time, it may be a little bit too simple. So, in the exam, it may be a little bit more complicated. There may be a little bit more tricks to it.
Dun dun dun.
Dun dun dun.
Always get you.
All right, so we'll take a look at this program and copy and paste it so that we can work on this. I don't know. I mean, what do you guys think? I mean, all the questions up to this point, are they kind of, it's okay, not too bad?
I like them the way they are.
I found them really hard. Maybe you should double down.
Yes, they're really difficult.
I'm gonna watch the video 5 times just to make sure I
Yeah.
got it.
Me too. That's why I wanted you to put the files online, that way I can go over them in more detail, study them.
All right, so we have this new program. Now this one does have recursion because we are invoking NT from inside NT itself. NT, in this case, actually stands for nothing because the subroutine actually doesn't do anything. Well, nothing that is of any value to the invocation itself. Okay. It just burns, CPU cycles. That's all. So we have comments, we have line number. We don't have any global variables in this case, so the pre has nothing to say. And then we are on the first line. The only line outside of the outside of the definition of a subroutine is line 7. This time, what do we use? Should we use return line number or should we use return info? Return line number would make it easier. You can use return info if you want to. It will still be using it would just be saying post. But just to be consistent with our terminology, we'll just use return line number in this case, because when line 7 is done, when the invocation is done, we just get to the end of the program and there's nothing else to do. Okay. Do you guys have any questions right there? Okay. All right. So what else do we have to do? Well, I'm not quite done yet with allocating columns, because we have a parameter, right? We have a parameter I in this case. So parameter I needs one more column, and it is a passed by value parameter, which means it behaves just like a local variable, except it has a known value that is specified by the invoke statement itself. The invoke statement that we are talking about is on line 7. It specifies a value of 2 to be the initial value of I. So that's why column D starts with an initial value of 2. Are we doing okay so far? And then we get into the subroutine and continue on to line 3. Line 3 is asking the question, is I less than 3, less than 8? Well, I has a value of 2, 2 is less than 8 is true, so we go on to line 4. Line 4 is another invoke statement. All right, so we have to set up the same 2 columns, return line number and I. Return line number in this case is not 5, it is line 6, because line 6 is the line that is logically following line 4. What about I? What should I put into column F? I'm using I times 2 to specify I. I is column D, or the I on the left-hand side refers to column D. It has a value of 2. 2 times 2 is 4. So the new column, which is column F, starts with a value of 4. Then we get into the subroutine again, starting on line 3. I this time is 4. 4 is less than 8 is also true. We go to line 4 again. And for the most part, we can just copy and paste in this case, except for the value of I. Because this time it is 4 times 2, which is 8. Then we get back to line 3 again. I is less than 8 is finally false. Because I is already 8. 8 is less than 8 is false. That means we don't have anything to do. This conditional statement has no else, okay, which is the equivalent of having an else, but there's nothing in the else portion. So that means we have to go to line 6. There's nothing really much to do. Line 6, says we have to deallocate. Well, first of all, we have to remember which line to go back to. We're returning back to line 6, so that's why we put a 6 here. And then the next thing we have to do with line 6, or row 12 of the trace, is to deallocate the 2 columns that we allocated earlier and indicate that these are now deallocated. Just like that. Now we're back to line 6. Oh, guess what? Line 6 has nothing else to do. So now we deallocate those 2 columns for this invocation. And it tells us to go back to line 6 again. So this time when we go back to line 6, we have to remember to go back to post this time. And also remember that these 2 columns are now deallocated. And then we continue at post. That means the trace is done. So that's why the subroutine really doesn't do anything, even though it seems like it's doing something to the code that is invoking it. There's nothing that it's not returning a value. It's not changing any pass by reference parameter, and it's not changing any global variables. In other words, it has no effect whatsoever other than testing whether we understand recursion or not. Any questions about this one? No questions? Go ahead and save it. And we have one more question to go. Question number 4. Question number 4, looks kind of, long, but it's really not too bad. Now this one is a little bit tricky because it combines, the concept of recursion, passing by value, and also having 2 invocations on the same line. So I would say that this one is a little bit more complicated than the previous 3 questions. But if you already understand the concepts, you just apply the concepts pretty much the same way, and it really should not be much more complicated than the other ones. So, all the indentations first. Let's take a quick look at the program first. We want to print the return value of subroutine X, and we are passing 1 to I. That's the parameter. Inside the subroutine, we check whether I equals to 0. If it does equal to 0, it's a simple case. We return the value of 1, and we're done. Otherwise, we are going to return the value of 2 separate invocations of X itself. In other words, it is recursive, but it really isn't much different from the other example that we have seen before, where we have on the line of a return, we have 2 invocations of the same subroutine. So this part, as far as that part is concerned, is not that much different. So we'll go ahead and trace it then. And this time in the trace, we need comments, we need line number, and there are no global variables in this case, so the precondition really has nothing to say. And we only have one single line outside of the definition of the subroutine, which is line 9. Line 9, the first thing it has to do is to invoke X. When X returns with a return value, then we can print that value out. So that means we have to use return info in this case to remind ourselves when the invocation of X is done, or when this invocation of X is done, we have to get back to line 9. And the only thing left to do on line 9 is to print that value out. But we also have to set up another column because when we're invoking x on line 9, we have a pass by value parameter, which is I, and I in this case starts with a value of 1, because that's exactly how it is specified on the line of invocation itself. When we set up after we set up the 2 columns, we can get into the subroutine. When we get into the subroutine, we start execution on line 3. And line 3 is just testing whether it is time to stop recursion or not. I equals to 0 is false because I has a value of 1. So now we have to go to the else case, which is on line 6. On line 6, we have 2 invocations of x. And you can resolve one or the other. I think the C programming language does not give you any guarantee when the operation, it doesn't guarantee which one is going to evaluate first. Okay? So that means we can start with the left-hand side or the right-hand side of the addition in this case. The only time the order of evaluation is guaranteed is when you're dealing with AND and OR. The logical operators, when you have AND and OR, it is guaranteed to be left to right. But when it is multiplication or addition and stuff like that, it can be in any particular order. Yep.
Earlier in the semester, I thought you said C evaluates from right to left.
Only when you're dealing with logical operators. It's only guaranteed when you're dealing with logical operators like OR and AND. But for all other operators, when you have 2 invocations, it can choose either way to do it. So in this case, but from our perspective, because we read from left to right, it makes more sense to just do it the same way as we usually do it. All right, so that means I'm going to deal with the left invoke x first, and then deal with the right invoke x. We need a return info in this case because we are returning back to line 6. We have unfinished business on line 6 to deal with, and we still have to execute a return statement, but we also have the other invoke statement that is still here. So I have to kind of put it here the same way as it was written on line 6. In other words, I'm only replacing the one invocation that I'm dealing with at this point with a question mark. The other one, I just leave it the way it is. And then we have the specified parameter I. Parameter I in this case is 1 minus 1, which is 0. Because we are passing I minus 1, but the I of the left-hand side of the right arrow refers to column D in this case, so that's 1, 1 minus 1 is 0. And then we get into the subroutine starting on line 3. Line 3 checks whether I equals to 0. This time it is true because column F has a value of 0. Then we go to line 4. Line 4 is very simple. All it does is to change the question mark to a 1. So we go to the return info cell, we copy and paste, we change the question mark from a question mark to a 1, and we're done. And then we move on, outside of the conditional statement, we go all the way to line 8, which is the end of the subroutine. On line 8, there are 2 things to do. One is to look up the return info cell to remind us that we have to go back to line 6. And then the second thing we have to do is to deallocate the 2 columns that we allocated earlier for this invocation. And then we're done. Now we're back on line 6. But line 6 doesn't really look like this anymore because the first invocation is already done and we know what it is returning. It is time to turn our attention to the second invocation of x. So once again, even though the invocation looks exactly the same, you cannot assume that they will return the same value. So you have to go through the process again to see whether it is what value it is returning this time. So we have to set up the same thing again. I'm just going to be a little bit lazy here. Except this time it is the second or the right invocation that we're dealing with. So that one gets replaced by a single question mark, but the first one is already resolved, so we cannot put a question mark here. It is already resolved to a value of 1. Are we doing okay so far with how the columns are set up? Okay. And now we are ready to go into the subroutine, starting on line 3. Line 3 says I equals to 0 is true because I, as a parameter, has a value of 0. So we go to line 4. Line 4 is returning a constant of 1. We take the return info cell, copy and paste it, change the question mark to a 1, and then that's it. Do not do any simplifications here. This is not the time to say that 1 plus 1 is 2. Okay, I know a lot of people, see this is so obvious, right? I have to change 1 plus 1 to 2. Do not do it. This is not the time to do it. Because all the return statement is going to do is to change the question mark to the return value, and that's all that it is supposed to do. And then after line 4, we go to line 8. Line 8 is the end of the subroutine. So once again, we look up the return info cell. It tells us that we have to continue on to line 6. And this is what line 6 looks like at this point. And then we also have to deallocate the 2 columns of this invocation. Now we're back on to line 6. But line 6 really looks like this now because we have just resolved the return values of both invocations of x. It becomes 1 plus 1. There's nothing else we have to do. 1 plus 1 is 2. So return 1 plus 1 is just returning 2. That means we are now ready to execute the return statement and then say print question mark should now be replaced by print 2 because we are returning a value of 2. And then after line 6, we get to line 8. On line 8, we do the usual thing. We remind ourselves where to go back to. We are supposed to go back onto line 9. And also we have to remember that these 2 columns are no longer needed. We have to deallocate those 2 columns. Now we're back onto line 9. Line 9 looks like this. There's nothing else that we have to do. We can just go ahead and print the value of 2 at this point. And then after that, we get to post, and we're done. Do we have any questions about this trace? No questions? That's it. I mean, we spent about 45 minutes, to go through those 4 questions. Any particular questions of the concepts? Not anything specific to these questions, just the concepts. Yep.
On
row 7.
The invoke on the far right. Invoke x1 I minus 1. What does the I minus 1 do?
You mean this I minus 1 here?
Yeah.
That is, but we are not dealing with it. Okay, what we're dealing with is the first invocation, which has I minus 1 as well. The I minus 1 of the right on the left hand side of the right arrow specifies the initial value of the parameter I that we are trying to set up at this point. Okay, so that means on the left hand side, when you look at this I minus 1, it is trying to use it. This is an expression that we can evaluate at this point on row 9 of the row 7 of the trace. We have to resolve what is I minus 1, but the only I that we can use to resolve that is the I of column D. So I minus 1 is the value of column D minus 1. Column D has a value of 1. 1 minus 1 is 0, and that's why the new parameter I has a value of 0.
And then since I equals 0, we return 1, since it's
Correct.
If state.
In the second invocation, yes. In the second invocation of x, because I has a value of 0, when we test it, it is true that I equals to 0. And then we move on to line 4. Line 4 says return a value of 1. That's why we copy and paste the return info cell and change the question mark, the only question mark, to a 1. Are we doing okay with this? Yeah. All right. So if we're okay with this and have no questions, I'm going to move on to new material. Yes. Okay.
All right, so
very good. Hit the brakes. Yeah.
Alright, so what I'm a little confused on is, so I see that on line 8, or sorry, I should say row 15. 8. Oh, sorry, line 15.
Row 15?
Yeah, row 15.
Mm-hmm.
So, we cancel out the return line. We know that we're returning to 9, right?
Well, at this point, okay, let's backtrack one more step. Okay, let's backtrack to line 4. Okay, the execution of line 4 of row 14 of the trace.
Mm-hmm.
Okay, when we execute line 4, we're just executing return 1, right?
Mm-hmm.
When we execute a return statement, all it does is to say, okay, let's copy and paste the return info cell and then change the question mark to the value that we are returning. And that's what it did. It took this question mark and turned it into a 1. Are we doing okay so far?
Mhm.
Okay. But we don't really care whether line 6 itself is a return statement or not. All we do is focus on the question mark. And it should only have one single question mark. Are we okay with that?
I get that.
Okay. So after line 4 is inside the then part of a conditional statement. When we're done with this, we have to get out of the entire conditional statement. And that means we get all the way to line 8. And that's why we are here. Is that okay?
Mm-hmm.
On line 8, which is the end of a subroutine, there are 2 things to do always at the end of a subroutine. The first thing you have to do is to figure out where am I supposed to go back to continue execution. And you can use the return info cell to tell you that we are supposed to go back to line 6. That's why I put 6 here. Is that okay?
There you go.
But when we did get back to line 6 really doesn't look like this anymore because both invocations are done at this point. So that's why we already know the first invocation has a return value of 1. The second invocation of x also has a return value of 1. And that's why we have 1 plus 1 here. That means we're ready to execute line 6 itself, which is the return statement. When we execute line 6, which is the return statement, we're returning a value of 2, which means we have to copy and paste the return info cell and then change the question mark to a value of 2 because we are returning a value of 2. Is that okay?
Mm-hmm.
All right, so that's once we're done with line 6, we get out of the conditional statement, we end up on line 8. It does the same thing. We look up the return info cell to tell us that we have to continue execution on line 9, and then after that we have to deallocate the 2 columns. When we did get back to line 9 looks like this, and therefore we are printing a value of 2.
Cool.
All right.
Thanks.
Mm-hmm. Yep.
Is this all the kind of material we're going to be going over in the test? Because we had some a lot harder stuff we were doing before spring break.
We are not going to put arrays into exam 2. In other words, there's no mixing of arrays and subroutine concepts in exam 2. So that will be in the final exam. Yep.
Okay. So I have a question.
Yep.
On line 6, the first time we execute that, I has a value of 1. So we do I minus 1, so that should be 0, shouldn't it?
Yep, right there.
Okay.
But we are not changing this value to 0.
Okay.
Because when we evaluate I minus 1, all we are asking is what is I minus 1. We are not saying change I to become I minus 1.
Okay. And then on the where it has the right arrow, is that changing it to?
You mean
is
this
that
right
moving it
arrow?
into- yeah.
That's why I use a right arrow instead of a left arrow, because the right arrow simply means we are specifying the initial value of the parameter,
Okay.
which is column F in this case.
Okay, and then so when you do the or when you do the if statement on line 3 for the first time, it returns 1 then. Okay. I think I got it. Or no, it's false.
It's false the first time. That's why we ended up on line 6, which has to invoke X again.
Okay.
In fact, twice, in order to resolve the expression on the right-hand side of return.
Okay, I think I have it.
Okay. So these are very simple test cases, but yet they exercise all the concepts that we have talked about in the class. Yep, go ahead.
Are there only 4 questions on the exam?
Yeah, there'll be 4 questions, but the complexity will be a little bit more than this. The trace won't be much longer. It will just be, a different combination, a different mix of concepts. Yep.
So you're still going to have all the same concepts? I mean, you're not going to add anything?
Well,
No
it will
more
still be the same
concepts.
concept. No more. The concept of arrays, will not be mixed in with the concepts of subroutines in exam 2.
Okay.
But it will be in the final exam.
All right, well, I would hope so.
Okay. So are we doing okay with this?
How long will the final be? Just out of curiosity.
The final exam has 2 hours.
Okay.
We
how
have
many
2 hours
questions?
scheduled. I'll just do it proportionally. Since we are only doing 4 questions or so in the regular class session, which is already an hour and how many minutes? It's about hour and 20. The final will only be what, 10 minutes more? Is it really the case? Only 10 minutes more than the usual?
If it's 2 hours, it'd be 40 minutes.
40 minutes more, yeah.
Like
So it'll
six
just be
questions.
proportional to that. So 80 minutes is 4 questions. So each question, so 6 questions instead of 4.
Okay.
Unless you guys want to have more. No?
Unless you're going for extra credit, then you know.
Well, the more questions you get, the less percentage each question is worth, which means, if you cannot answer one particular question, the impact of that is less as well. So there's a certain advantage having more questions, and each one carry less points. All right, so if there are no questions, I'll go ahead and save this file, and then we'll move on to talk about some new concepts, which will not be in exam 2, but it will be in the final exam. All right. How many of you have started to use Google Documents? I use it for just about everything. Mhm.
It's really nice for like group projects and stuff like that for
Yep.
our classes.
Google Documents. All right, so we are moving on to types and records. And this is a very interesting topic because it is related. This is how object-oriented programming started. How many people have at least heard of the term OOPS, object-oriented program? OOP, just OOP. Object-oriented programming? Okay, very good. So what do you guys know about object-oriented programming?
There's objects.
Yes, objects. It's a fancy term, okay? What object-oriented programming is really just a way of looking at things. Now, there are programming languages like C++ and Visual Basic and so on and so forth that have specific language elements to help you design programs using object-oriented programming. But for the most part, you can do object-oriented programming using any programming language. I can do that in assembly language programming, which is kind of like, assembly language programming is more like building big structures using grains of sand. C is more like using Lego blocks, and the Visual Basic is having much larger building blocks. You just kind of put things together. It's much easier to put things together, but then you don't have as much control either. Okay, if Microsoft doesn't give you a particular block to do something, then it will be difficult to make that block yourself. Versus in assembly language programming, because you're building everything using very small, fine components, you can actually design components any way you want. You can design very tricky components, you can design very elegant components, very efficient components, because the tool does not limit you whatsoever what kind of program you can write. But then you also have to assume the responsibility to debug everything. So there are trade-offs. But back to this particular topic, the whole concept of a record, which is down here, is the origin of object-oriented programming. We probably won't get into object-oriented programming in this class, but this gets you closer to object-oriented programming. We'll probably not read the notes at this point, but what I will do is to give you guys an analogy first, okay? So that you understand the necessity of the concept of a record, or a way to kind of put things into one single container. Go ahead.
You're making comparisons or analogies. If Lego block is C++, what is OOP? Is that like a floor?
C is basically procedural, which is Lego blocks, and then C++ is more like you have big blocks already. You don't have just Lego blocks that have axles and gears and whatnot. You have the entire transmission done. You have the entire engine done. You're just putting those things together, and that's more like that's kind of what Visual Basic programming is about. You have much larger components, and you're just connecting those components.
And OOP is?
OOP is that. It's just like that. It's designed so that you don't need to look into how something is done. This is an engine block. This is fuel intake. This is exhaust. This is the exhaust port. This is the drive axle. You don't need to know what is inside the engine. It may be internal combustion. It can be it may be a diesel engine, a gasoline engine. You don't really need to care. Whereas when you're writing in assembly, then you have to know what is inside the combustion chamber. You have to know how the valves works. You have to know, how to tension the springs, of the valves, and so on and so forth. So one, needs a lot of attention to details. The other one is just looking at the object as a whole, and then say, okay, what is the interface to this object here? Well, in order for the engine to work, it needs fuel, it needs air, okay, it needs motor oil, but it also needs, exhaust, for the exhaust gas to get out. But how is it using the fuel and so that the combustion works, and then you have the exhaust gas? You don't need to know. Do you understand the difference? One has to look into the engine to see how it works. The other one looks at the engine from the outside and just say, what does it need in order to work? Okay. But getting back to this, let's focus on records. Okay. And I'm not going to use the example in this case. I'm not going to read the example. So I just want you guys to kind of imagine how many people still have to fill in like paper forms these days. I know most of us don't have to do that anymore, but I hope you still remember the last time you have to fill in some paper forms. So let's say you're just trying to register with a different community college, and they don't have any online registration process. You have to do everything on paper. Okay. And not only that, instead of having one form, that we all know what forms look like. Let me just try to pop up a image of a form. So we'll just go for student registration form and go for images. Okay, so we'll just pick out one particular image here. There we go. Come on, scroll. Oh, it's all right. So here's a student form, and let me see if that works. It's not very exotic. It's a very typical form for student registration. How many different items do we have on this form? Just give me a rough number. It doesn't have to be exact.
A lot.
30 to 40 items. I would kind of guess. Guesstimate is between 30 to 40 items. What if instead of having one form with 30 or 40 fields to fill in, I give you one little slip of paper for each field that you have to fill in?
That would be awesome.
So in other words, instead of one single sheet of paper like this, I'm giving you a little pile of tiny little pieces of paper so that you can fill in, legal name, surname is one little slip of paper. First name is another piece of paper. Middle name is yet another piece of paper. Usual first name, another piece of paper. Okay, let's look at the address. Mailing address, street number, one little slip of paper. Street name, another piece of paper. City, another piece of paper, and so on and so forth. So you will end up with a big pile of little pieces of paper. Okay, why is that not such a good idea?
Well, if you mix up with everybody else's little piles or big piles of pieces of paper.
That's exactly it. Okay, that was exactly it. Because now, when you go to the registration office, you all line up. The same college probably has a long line of registration. People who want to go through the registration process, right? So let's just say that you bump into somebody else, and you both, drop the little pile of paper, and you guys now start to try to piece everything back together. What are the chances that you might accidentally pick up the wrong piece from the other person?
Pretty good.
Pretty good, right? Yep.
It'd be hard to find any kind of information throughout that.
It'll be difficult to find information, exactly. And it's just not intuitive, okay? So sometimes it makes sense to say that, well, each individual item is useful, but I think putting these things into one single form or into one single collection or box, whatever you want to call it, a container of some kind, makes even more sense.
Wouldn't that be what you would use an array for, or something like that?
Well, it's a little bit different from an array, and we'll get to that part later. Okay, but that's a good point to remind me to talk about that point too. What about now? I'm still getting back to why having a big pile of little paper is worse than having a big piece of paper with a lot of different fields to enter. what if I want to make a photocopy of this? Well, with this, once you fill in the entire form, which will take you a while, if I want to make a photocopy of this, I just put it onto the copier, push a button, one copy, and I'm done. Versus, I would end up with like 40 or 50 little pieces of paper, and each one needs its own photocopy when I want to photocopy the entire thing. So being able to treat the entire thing as one single item sometimes is very useful. Okay. Now getting back to your point, whether arrays can help us with this or not, the answer is not really. The reason why arrays cannot be helpful in this case is because the kind of information that we want to contain here are of different types. In other words, okay, let's look at this field here.
Oh gosh.
Refresh. Yeah.
Remember, it's not a bug, it's a feature.
So we have excuses to charge you for the upgrade.
Yes.
Yeah, certain companies use that strategy. You just bought Windows Vista. Guess what? We have just improved it, and now it's called Windows 7. Please pay again.
No, an even worse one was Windows 98 SE to ME.
Now, Windows 98 is a good example because if you had Windows 98, you have to pay for Windows 98 SE. The second edition is not considered an upgrade that is free from Microsoft. It is considered a different operating system, so you have to pay for that upgrade.
Yeah, but do you remember when Windows ME came out? It broke so many people's computers.
Yeah. Yeah, the best operating system from Microsoft is probably Windows XP. It was very stable and very efficient.
I should have never given up on XP. Just keep it in use.
I still have it. All right, so let's take a look at these different fields. If you look at this field here, does this student live with you? What kind of field do you think it is? Just corresponding to the different types of variables that we have talked about in this class. It's a yes/no answer. Doesn't that kind of ring a bell? Like Boolean, true, false. Okay. And then we can look at something else here. Telephone number and cell phone number. Those are all kind of numeric. Okay, they have digits. When you look at names, they have alphanumeric or mostly letters and from the alphabet. In other words, within the same form, you would have different fields that have different types. Okay, they're not necessarily of the same type. Sometimes you have a form that has everything of the same type, but sometimes not. We can also look at something else, which would be a very good example here as well. When you look at date of month, day, and year, those are all numbers. In fact, you want to enforce the fact that month can only go from 1 to 12. Days will have to match the month itself, and then the year also has to be within a reasonable range. Okay, so that means within a form you can have many different items, but these different items can have different types. Some are numbers, some have a specific format to it, like a zip code has a specific format. Some are more free form, like surname and first name can be more free form, and so on and so forth. And that part makes it impossible to use arrays to do the same thing, because what is one restriction of using an array?
They all have to be the same type.
They all have to be the same kind, okay? And in the form, we do not have fields that are all of the same form. Now there's another thing that makes arrays not very useful for this purpose. How do we identify individual items inside an array? It's a number, it's an index, right? We start with 0 and it goes all the way to bar a bar minus 1, or the number of items minus 1. Would you want to remember that this is element 0, element 1, element 2, element 3, and so on? Because then in your mind, you cannot just say that, oh, I just want to look up the guardian relationship here. No, you have to remember what number it is. So arrays is a good starting point, but it doesn't give us everything that we need when we're dealing with a form. And that's why we have records. Okay, this is the whole idea of why we have records. A record is basically a collection of items, and each item can be of a different type. Are we doing okay so far? So a form is basically a record.
So
now that we are done with that one, let's go back and talk about types, because we have already dealt with different types in this class. We have dealt with integers, right? I mean, there are certain things we can do with numbers, particularly integers. What can we do with integers? I mean, it's all kind of listed here on this slide. We can compare integers, okay? Because we can say, you know, when you have two integers, we can tell that at least we can know that there are three possible relationships. They are the same. This one is greater than the other one, or the other one is greater than this one. Those are the only three possible ways of ordering when you're dealing with integers. We know that we can do other things with integers. We can multiply two integers and end up with another integer. We can compare two integers but end up with a Boolean in this case. What about this? What about, let me give you an example and see what you guys think of this. What is the result of 45 or not 5? Does it make sense to you? What do you expect? What does the or, you know, the disjunction operator expect from both sides? Booleans. Booleans, right? You know, basically true, false values. 45 is not a true, false value. What about not? Not expects a Boolean as well. We know not true is false. We know not false is true. But those are the only two values that we can negate. 5 is not one of those things that can be negated. So that means, you know, the type of something also dictates where it can go and where it cannot go. In other words, a number doesn't belong here. Well, we can also do something, you know, just as senseless. What is true times false plus true? It makes no sense, right? Because true, false, you know, multiplication require numbers. It requires, you know, numbers on both sides so that, you know, the end result is another number. True is not a number. False is not a number. So true times false really makes no sense. And that's what a type is. A type is basically saying, with this particular value, what can you do with it and what can't you do with it? It defines, you know, its role. Where does it fit in the program? Are we doing okay so far with the concept of a type? Okay. So now that we are done with these two particular examples, you know, we are done with these two. And one thing that we haven't really talked about in this class is called, you know, a string, or how we represent text. With numbers and Booleans, we can deal with most concepts related to the logic of a program. But we haven't, in this class, we haven't really talked about how do we represent other things like street addresses, first names, last names, course titles, and so on and so forth. We haven't really talked about that. And the concept is called a string. A string is basically, you know, some sort of text value. Like, you know, my first name is, you know, a string, my last name is a string, and so on and so forth. And I cannot remember what this, you know, backward exclamation mark was supposed to be. I think it's supposed to be a math operator to basically say it doesn't make any sense to say tag times volume. Okay, it just doesn't make any sense. Yep.
So a string is a alphanumeric, but not an integer.
No, it can be an integer. That can be confusing. Yeah, it can be an integer. It can look like an integer, but it's not an integer.
It looks like it, but it doesn't take the function of an integer.
It cannot take the place of an integer. Correct.
Like a street address.
Like a street address, exactly.
It's a number, but it's a useless number because it's just symbolic.
That's a very deep question because it depends on the programming language that you're dealing with. If you're dealing with, since most of you are moving on to C and C++ in cisp360, then the string representing 1, 2, 3 is different from the number 123. One can be, 123 without the double quotes is a number. You can multiply, you can subtract, you can compare, and so on. But with double quotes, which means it is now a string, it is really just literally the letters or the digits, in this case 1, 2, 3, it has no numerical value represented. It really is just the digit 1, the digit 2, and the digit 3. You can still quote unquote compare, but the comparison doesn't follow the rules of number comparison anymore. It is really just a lexical comparison of, okay, here's the digit 1 compared to the other thing, the first character of the next thing. And then, so it doesn't work the same way. I can give you one quick example to illustrate, okay, 1, 2, 3, 5, and 1, 2, 3, 4, 0. Okay? When these two are both numbers, which one is larger? Pretty obvious, because this one is 12,340, and the other one is 1,235. But when you look at these as strings, then the rules of comparison become different. Because the rule of comparison, when these are looked at as strings or text values, then the way you compare is to say, are these the same? 1 and 1 are the same? Okay, fine, I cannot determine the order of the two. 2 and 2 are the same. 3 and 3 are the same. Oh, these are different. Which one is larger? 5 is larger. So when you compare these two things as text value or as strings, 1, 2, 3, 5 is considered larger than 1, 2, 3, 4, 0. Much like when you look at TAC versus, I don't know.
Taz. Taz.
I was gonna say, just capitalize the first letter.
How about this, Taylor? Okay. Well, you compare uppercase with uppercase T. They are the same. I cannot determine the order of these two. You compare lowercase a. I cannot determine the order. Then you can now compare, K versus I. K lexically is after I. So the computer will say that tag, if both of these are to be appear in a dictionary, tag will appear after Taylor. Does that make sense? It's using the same rules to compare these when they are considered as strings. When you use double quotes, they are no longer numerical values. They are now really just literally the digits 1, 2, 3, 5, and the 1, 2, 3, 4, 0. So when you compare these two, then this will be the case where it is where you can make a difference, and it will say that 5 is larger than 4, and therefore this particular string 1, 2, 3, 5 will be lexically after the string 1, 2, 3, 4, 0. Yep.
So you're looking at street addresses, and the lower numbers are to the east and moving west.
Right.
If the numbers get greater, that means it's further west.
Right.
So before is east and after is west. At that point, we had 889 and then 1230. It's going to assume that 889 is
correct.
Is greater than and further down the street.
That is
when
correct.
Really, it's actually not.
Correct. Yeah, because it's not looking at those as numerical values. The computer is looking at it as simply just letters to compare. Okay. So we are running out of time today. When you read the notes, at least read up to this portion here. Try to read the records portion, section 5 of this notes, okay? Because that's what we will talk about on Thursday.
Can you just sign this one?
Okay, sure.
Is it still recording?
I turned it on.
When it's so